Welcome. You can relax now. The day is over, and there's nothing you need to do or think about. Just get comfortable and let your breathing slow down. Tonight, we're going to take a quiet look at the Great Pyramid. Not in a rushed or complicated way, just steady, simple, and calm. We'll talk about what makes the pyramid so mysterious, who it was built for, its documentation, and the unseen forces that shape the pyramid itself. There's no need to remember details, you can simply listen. If your mind wanders, that's okay. If you fall asleep, that's even better. This is a space to rest, to slow down, and to let the night do its work. So settle in, get comfortable, and let's begin. Night falls over the Giza Plateau. The desert cools, the stars brighten, and the Great Pyramid rises in silence. The Great Pyramid of Giza is the largest and oldest of the three pyramids. Most historians agree it was built around 2580 BCE during the reign of King Khufu. It is made of more than 2 million stone blocks, each weighing several tons. The pyramid was likely built as a tomb, meant to help the king reach the afterlife. This explanation sounds simple, but the structure itself is not. What makes the pyramid so mysterious is its precision. The stones fit together so tightly that even today, it is hard to slide a blade between them. The pyramid is almost perfectly aligned with the four main directions: north, south, east, and west. Its sides are nearly equal, and its base is remarkably level. For a civilization without modern machines, this level of accuracy is surprising. Historians believe the ancient Egyptians used simple tools like copper chisels, wooden sleds, ropes, and ramps. Workers may have dragged stones across wet sand to reduce friction. Large teams likely worked together for many years. Recent discoveries of workers' villages suggest the builders were not slaves, but skilled laborers who were fed and housed by the state. Still, many questions remain. No clear record explains exactly how the stones were lifted so high. Some theories suggest long straight ramps, others propose spiral ramps built around the pyramid. Each idea has problems. Straight ramps would have needed to be extremely long. Spiral ramps would have been hard to build without blocking the view needed for precise alignment. Another mystery is the pyramid's purpose. While it is called a tomb, no mummy has ever been found inside it. The inner chambers are complex, with narrow passages, air shafts, and heavy stone blocks designed to seal rooms. Some scholars wonder if the pyramid had religious or symbolic meanings beyond burial, linked to the stars or the journey of the soul. The Great Pyramid also unsettles historians because it seems to appear suddenly in history. Earlier pyramids exist, but none match its size or perfection. After it was built, later pyramids were smaller and less precise. This raises a puzzling question. How did the builders achieve such mastery so early, and why was it never repeated? According to the accepted historical story, the Great Pyramid was built for Pharaoh Khufu, also known by the Greek name Cheops. Khufu ruled Egypt during the 4th dynasty, around 2580 BC. Ancient records, later writings, and archaeological evidence link his name to the pyramid, making him the most widely accepted owner of the monument. For many historians, this connection explains who ordered the pyramid and when it was built. The pyramid is believed to have been designed as Khufu's royal tomb. In ancient Egyptian belief, death was not the end, but a journey into another life. The pharaoh was seen as a god on earth, and after death, His soul needed protection, guidance, and a secure place to rest. The pyramid was meant to serve this purpose. Its massive size symbolized power and eternal life, while its shape may have represented the rays of the sun, helping the king ascend to the heavens. Inside the Great Pyramid are several chambers, including the King's Chamber, the Queen's Chamber, and the Grand Gallery. These spaces were carefully planned, with narrow passages and heavy stone blocks meant to prevent robbers from entering. The King's Chamber contains a large granite sarcophagus, believed to have held Khufu's body. Though no mummy was found, historians argue that tomb robbers likely removed it long ago. One of the most striking claims about the Great Pyramid is the speed of its construction. It is often said that around 2.3 million stone blocks were placed in just 20 years. If this is true, it would mean that workers set one block every few minutes, day and night, for 2 decades. This idea amazes many people and raises serious questions about how such a task was organized. Supporters of the traditional view argue that Egypt had the manpower and resources to do it. During the Nile's flooding season, many farmers could not work their fields and were instead employed on state projects. Large teams of workers may have been divided into smaller groups, each responsible for specific tasks such as cutting stone, transporting it, or placing it in position. Strong leadership and careful planning would have been essential. Ancient tools were simple but effective. Copper tools, stone hammers, wooden sleds, ropes and levers were likely used. Workers may have relied on ramps, gradually raising the stones as the pyramid grew taller. Over time, the pyramid took shape, layer by layer, until it reached its original height of about 146 meters. Even within the accepted story, however, doubts remain. No detailed construction records from Khufu's time explain exactly how the pyramid was built. The timeline is based on estimates rather than clear proof. While Khufu's name appears in nearby inscriptions, it is mostly absent inside the pyramid itself. Still, for mainstream historians, the story of Pharaoh Khufu remains the most reasonable explanation. It fits within known Egyptian beliefs, social systems, and architectural traditions. Yet the sheer scale and precision of the Great Pyramid continue to push this explanation to its limits, leaving space for debate and wonder. When the accepted story of the Great Pyramid is examined closely, cracks begin to appear, especially in the idea of how the work was done. The labor narrative claims that ordinary human workers, using simple tools, placed about 2.3 million stone blocks in roughly 20 years. On paper, it sounds impressive. In practice, it raises serious problems that historians and engineers still struggle to explain. First is the issue of time. If the pyramid took 20 years to build, that equals about 7,300 days. Dividing 2.3 million stones by that number means an average of more than 300 blocks placed every single day. This calculation does not account for rest days, injuries, bad weather, or the time needed to quarry, shape, transport, and lift each stone. It also assumes perfect efficiency from start to finish, something no large human project has ever achieved. Many of the stones weighed between 2 and 3 tons, while some granite blocks inside the pyramid weighed much more. Moving such heavy stones from quarries miles away, then lifting them with precision to higher levels, would have required enormous effort. Even with thousands of workers, the pace needed seems extreme. The idea that this speed was maintained for 2 decades stretches belief. The tools of the time add another layer of doubt. Ancient Egyptians worked during the Bronze Age, using copper tools, stone hammers, wooden sleds, ropes, and simple levers. Copper is soft and wears down quickly. especially when cutting hard stone like granite. Tools would have needed constant replacement, slowing work further. There is little physical evidence of large numbers of worn tools or repair sites on the scale such a project would demand. Ramps are often suggested as the solution, but they create problems of their own. A straight ramp tall enough to reach the upper levels would have been massive, possibly larger than the pyramid itself. Building, maintaining, and later removing such a ramp would have required extra labor and time, yet there is no clear archaeological evidence of one. Spiral or internal ramp theories sound clever, but no solid proof confirms their use. Then there is the human cost. The labor narrative assumes that workers could sustain heavy physical work for long periods without modern nutrition, medicine, or machinery. Dragging multi-ton stones under the hot Egyptian sun day after day would have pushed human endurance to its limits. While Egypt was well organized, even the most disciplined workforce has physical boundaries. Engineering reality also demands accuracy. The pyramid is not just big, it is precise. Its sides are aligned with near-perfect cardinal directions, and its stones are set with remarkable consistency. Achieving this while racing against time makes the traditional narrative even harder to accept. Precision usually slows construction, not speeds it up. Much of what the world believes about the Great Pyramid does not come from Egyptian records, but from one man, Herodotus. He was a Greek writer who lived around 450 BC, nearly 2,000 years after the pyramid was built. Often called the father of history, Herodotus traveled widely and wrote down stories about the lands he visited. But his accounts of Egypt remind us how fragile ancient history can be. Herodotus never saw the Great Pyramid being built. By the time he arrived in Egypt, it was already ancient. Everything he wrote about its construction came from conversations with Egyptian priests and guides. These men were not eyewitnesses either. They were repeating stories passed down through generations, shaped by memory, belief, and tradition. In other words, Herodotus was recording second-hand information, not direct evidence. This matters because oral stories change over time. Details are lost, numbers grow larger, and meaning shifts. When priests spoke to Herodotus, they may have mixed history with symbolism, religious teaching, or even national pride. A story told to impress a foreign visitor does not always aim for accuracy. It aims to inspire awe. Herodotus wrote that 100,000 men worked on the pyramid in rotating shifts and that the suffering of the people was great. He described long years of labor, misery, and hardship. Yet modern archaeology paints a different picture. Excavations near Giza suggest the workers were organized, fed well, and cared for. This clash raises an important question. How much of Herodotus' story reflects reality, and how much reflects drama? Another problem is Herodotus' style. He did not separate myth from fact the way modern historians try to do. His writings include talking animals, divine signs, curses, and magical explanations. He often reported stories exactly as he heard them, even when they contradicted each other. Sometimes he admitted doubt. Other times, he let the story stand on its own, no matter how strange it sounded. Numbers are a common issue in his work. Ancient writers often exaggerated figures to emphasize greatness. Saying thousands or hundreds of thousands did not always mean an exact count. It meant a lot. When Herodotus speaks of massive labor forces and endless suffering, he may be using language meant to convey scale, not precision. There is also the question of bias. Greek writers often viewed foreign rulers, especially powerful kings, as tyrants. Khufu, in Herodotus's telling, appears cruel and selfish, forcing the people to build his tomb. This image fits Greek ideas about despotic rulers, but may not reflect Egyptian reality. In 1837, a British army officer named Colonel Howard Vyse arrived at the Great Pyramid with one goal: to make a name for himself. At the time, Egypt was becoming a center of fascination for European scholars, collectors, and adventurers. Discoveries brought fame, funding, and influence. Vyse wanted to be remembered as the man who unlocked the pyramid's secrets. Instead of careful digging, Vyse used force. He blasted his way into sealed chambers using gunpowder. Walls were broken, stone was cracked, and ancient spaces were damaged forever. This method shocked even some people in his own time, but it worked. Vyse reached previously unknown chambers above the king's chamber, now called the relieving chambers. Inside these spaces, his team found something unexpected: red painted markings on the stone blocks. These markings included quarry symbols, lines, and most importantly, cartouches, oval shapes containing royal names. Among them was the name of Khufu. If genuine, these markings directly linked the Great Pyramid to Pharaoh Khufu and seemed to settle the debate about who built it. The discovery was quickly celebrated. For historians who wanted a clear answer, this was perfect evidence. The cartouches appeared to confirm the traditional story. Khufu ordered the pyramid, and workers marked the stones during construction. Academic circles accepted the findings almost immediately. Textbooks, museums, and lectures repeated the conclusion with confidence. But the story is not that simple. The red marks were found only in areas no one had seen before, areas opened by Vyse himself. There were no independent witnesses present during the first discovery. Much of the documentation came from Vyse's own notes and sketches. This raised early concerns, though they were largely ignored at the time. Vyse was also under pressure. He was competing with other explorers in Egypt and had already failed to make major discoveries elsewhere. His funding and reputation were at risk. Finding Khufu's name inside the pyramid would instantly secure his place in history. Questions soon followed. Some scholars noticed that one of the cartouches appeared to use a form of Khufu's name that was unusual for the period. Others pointed out that the paint used looked more like surface markings than deeply aged inscriptions. There were also spelling issues that did not fully match known royal names from Khufu's time. Despite these concerns, the academic world had little appetite for doubt. The cartouches fit the accepted story too well. Challenging them would mean reopening the entire question of the pyramid's origin, a task few were willing to take on. Once the red cartouches were accepted as proof that Khufu built the Great Pyramid, few people wanted to question them. But over time, researchers who looked more closely began to notice things that did not quite add up. The doubts did not come from wild imagination, but from basic observation and logic. The first issue is the way the markings were made. In most Egyptian monuments, royal names were carved into stone. Carving was permanent, respectful, and meant to last forever. Yet the cartouches in the relieving chambers were not carved at all. They were painted in red pigment directly onto rough stone surfaces that were never meant to be seen. This alone raised eyebrows. Why would workers carefully mark a king's sacred name with paint instead of carving it, especially inside a structure built for eternity? Supporters of the cartouches argue that these were simple construction marks, not religious inscriptions. But even construction marks in other pyramids tend to follow known patterns and styles. The Great Pyramid cartouches feel inconsistent with that tradition. They appear rushed, uneven, and oddly placed. Spelling and style create another problem. Egyptologists later noticed that one of the names attributed to Khufu used an unusual form that does not clearly match how his name was written during his reign. Ancient Egyptian writing followed strict rules, especially for royal names. Errors were rare, particularly in something as important as a cartouche. Mistakes in spelling suggest either carelessness that does not fit Egyptian practice or authorship by someone less familiar with Old Kingdom writing. There is also the issue of documentation. Colonel Weiss kept notes of his discoveries, but the cartouches do not appear clearly or consistently in his earliest records. Some references are vague, others seem added later, after the excitement had already grown. This absence is troubling. If such a major discovery truly happened exactly as described, why was it not carefully recorded from the very start? Equally important is what is missing: independent confirmation. No neutral observers verified the markings at the moment they were found. Most of what we know comes from Weiss and his close associates. In modern archaeology, this would never be considered acceptable evidence. As questions grew, scientists began examining the pigment itself. Modern analysis of the red paint has revealed more reasons for caution. Tests suggest the pigment is iron oxide, commonly known as red ochre. While iron oxide was used in ancient Egypt, it was also widely used in the 19th century for marking stone, machinery, and construction materials. This makes it difficult to claim the pigment is ancient based on composition alone. More concerning are signs of layering. In some areas, the paint appears to sit on top of dust or mineral deposits rather than beneath them. If the markings were truly ancient, they should show signs of age consistent with thousands of years of exposure, even in sealed chambers. Instead, some marks appear surprisingly fresh. Microscopic analysis has also raised questions about how the paint was applied. Brush fibers and stroke patterns in certain samples resemble modern brushes more than ancient tools. While this does not prove forgery, it adds another layer of doubt that cannot be easily dismissed. Perhaps the biggest problem is access. The relieving chambers are tightly controlled, and permission for advanced testing is rarely granted. Independent researchers have repeatedly asked for full chemical and forensic analysis, but access remains limited. Without transparent testing, the debate cannot be settled. One of the strangest things about the Great Pyramid is not what we see, but what we do not see. For a project said to be the greatest achievement of Khufu's reign, there is a deep and uncomfortable silence in the archaeological record. No detailed construction records survive from his time. No step-by-step plans. No lists explaining how the stones were moved. No official account celebrating the completion of the pyramid. For something so massive, the absence is striking. Ancient Egypt was not a quiet civilization when it came to record keeping. Kings proudly carved their victories, temples, and building projects into stone walls. Officials wrote on papyrus about food supplies, labor groups, and state projects. Yet for the Great Pyramid, the most ambitious structure ever attempted, there is nothing directly describing its construction. This absence forces historians to rely on guesses, later stories, and indirect clues. There are no wall reliefs from Khufu's time showing the pyramid being built, no images of workers hauling stones up ramps, no scenes of engineers measuring angles or priests blessing the foundation. This is unusual. Later Egyptian monuments often included such scenes, especially when rulers wanted to show power, order, and divine approval. Even more puzzling is the contrast with later pyramids. After Khufu, other pharaohs built smaller and less precise pyramids. Yet for these later structures, we find more evidence, reliefs, inscriptions and papyri that mention construction work, labor teams, and materials. In some cases, we even know the names of officials in charge. The smaller the pyramid, the clearer the paper trail becomes. This raises an uncomfortable question. Why is the greatest pyramid the least documented? Some historians argue that records were lost over time. That is possible, but it does not fully explain why nothing remains. When silence is complete, it invites doubt. Not far from the Great Pyramid lies a site often called the Worker Village. Archaeologists uncovered housing areas, bakeries, storage rooms, and burial sites. These discoveries are frequently presented as proof that large teams of workers lived near Giza while building the pyramid. At first glance, this seems to support the traditional story, but when the evidence is examined more closely, a paradox appears. The village shows signs of long-term habitation. People lived there for extended periods with organized food production, medical care, and proper burials. This suggests stability, not a short-term rush to complete a massive project under extreme time pressure. The lifestyle looks more like ongoing service than non-stop emergency construction. Even more interesting are signs of maintenance rather than initial building. Some structures show repairs, reuse, and adaptation over time. This implies that workers may have been maintaining, modifying, or servicing existing structures rather than creating something entirely new from scratch. There is also the issue of scale. The size of the village does not clearly match the enormous workforce often claimed for pyramid construction. If tens of thousands of workers were placing hundreds of stones per day, we might expect a much larger and more chaotic settlement. Instead, what we see is organized and controlled. This leads to a quiet but serious possibility. The workers may not have been building the Great Pyramid from the ground up. They may have been involved in finishing work, internal adjustments, repairs, or later reuse of the site. Over centuries, a monument like the pyramid would have required care, protection, and ritual upkeep. If this is true, then the village does not explain how the pyramid was first built. It only shows that people worked there later. When geologists look closely at the Great Pyramid, they notice something strange about the stones, especially the lower ones. Some blocks show patterns of erosion that do not match wind or sand. Instead, they appear worn down by water. This is odd because Egypt is mostly desert now, and the Nile doesn't flood the plateau where the pyramid stands. Robert Schoch, a geologist, studied these marks in detail. He concluded that they might have been caused by heavy rainfall long before the accepted construction date. If this is true, the climate of Giza thousands of years ago was very different, wetter and more prone to storms than today. This raises difficult questions. If the pyramid stones were carved and placed during a wetter period, could it have been built earlier than historians claim? Or does it suggest that the builders worked under harsher natural conditions than expected? Either way, the geological evidence does not fit neatly with the traditional timeline, creating another layer of mystery around the pyramid. To get closer to the truth, scientists have tried carbon dating the pyramid's materials. Mortar, made from limestone, and organic additives is a common target for testing. However, this method comes with major problems. Mortar often includes bits of older organic material, which can give dates that are much older than the actual construction. Moreover, results vary widely between different samples and testing periods. Some tests suggest dates consistent with Khufu's reign, while others point to thousands of years earlier. No single result is completely reliable, and the inconsistencies make it hard to form a solid timeline. Even when multiple laboratories perform carbon dating independently, the outcomes rarely agree. This creates a puzzling scenario. The very tools meant to clarify the pyramid's age instead deepen the uncertainty. These contradictions leave researchers questioning the official history and wondering if some aspects of the Great Pyramid story have been oversimplified or misunderstood entirely. Together, the geological evidence and carbon dating inconsistencies challenge the idea that we fully understand when and how the Great Pyramid was built. They suggest that the story might be more complicated than the neat version of Pharaoh Khufu commissioning his tomb. In recent years, researchers uncovered a small but remarkable artifact inside the Great Pyramid, a fragment of cedar wood. What makes this discovery so surprising is its age. Carbon dating placed it between 3510 and 3400 BC, well before the reign of Pharaoh Khufu, who supposedly built the pyramid around 2580 BC. This tiny piece of wood challenges the traditional story. If it truly dates back nearly 1,000 years earlier, it could mean that some parts of the pyramid, or at least its planning and initial construction, started long before Khufu. Perhaps earlier builders experimented with construction techniques that later generations perfected. Or maybe the pyramid itself was built on top of an even older structure. Whatever the explanation, the cedar fragment forces historians and archaeologists to reconsider the pyramid's timeline. It's a subtle clue, almost hidden, but its implications are enormous. The Great Pyramid might be older than the official records suggest, hinting at lost chapters in human history. Another mystery of the Great Pyramid is its precision. The pyramid covers more than 13 acres, yet its base is nearly perfectly level. The deviation from true horizontal is only a few centimeters across the entire structure. An extraordinary achievement even with today's tools. Equally astonishing is the alignment of the pyramid to true north. The builders managed to align the massive structure within a few arc minutes of accuracy. For reference, this is like hitting the bullseye on a dartboard from miles away. Ancient Egyptians had simple tools made of wood, rope, and basic measuring instruments. How they achieved such astronomical precision remains a mystery. Then there are the stone joints. Some blocks fit together so tightly that a sheet of paper cannot be inserted between them. This level of craftsmanship seems almost impossible using Bronze Age technology, especially when considering the sheer size and weight of each stone. These feats suggest knowledge and techniques that we still don't fully understand. Some researchers propose advanced surveying methods, lost tools, or even knowledge passed down from earlier civilizations. Others remain skeptical, but the evidence is undeniable. The Great Pyramid is not just a massive tomb, it's a monument to engineering skill that surpasses what we would expect from the tools and technology of the time. Inside the Great Pyramid, researchers have found something that raises eyebrows: strange spiral marks on some of the granite blocks. These marks suggest a drilling technique far more advanced than what we would expect from the Bronze Age. The grooves indicate that the material was cut at feed rates similar to what modern machinery can achieve. When scientists tried to replicate these cuts using copper tools, the type supposedly available to the ancient Egyptians, they failed. Copper is soft and wears down quickly, especially against hard granite. The marks left by experimental attempts were rough and uneven, nothing like the precision seen in the pyramid. This raises a question. Did the builders have access to tools or techniques that we no longer know about? Were they using some method of cutting and shaping stone that has been lost to history? The evidence strongly suggests that the level of skill and technology involved was far beyond what historians traditionally credit to the Egyptians of Khufu's era. Another challenge is moving the stones. Some granite blocks in the pyramid weigh up to 80 tons, an enormous load even by modern standards. The traditional explanation is that massive ramps were built to drag the stones into place, but here too, the evidence is weak. Archaeologists have found no clear remains of ramps large enough to explain how all these stones were moved. Modern engineers have attempted to recreate the process. Experiments with teams of workers, sledges, and ramps fail when applied to stones of the pyramid's largest sizes. Even with hundreds of people and careful planning, lifting or dragging the blocks over long distances proved nearly impossible without breaking or damaging them. These difficulties highlight a gap between theory and reality. While smaller pyramids could conceivably be built with ramps and manpower, the Great Pyramid stretches these explanations to the breaking point. The question remains, how did the builders transport, shape, and assemble stones of such size and precision without leaving clear evidence of their methods? Together, the tool marks and ramp failures point to a simple truth. The Great Pyramid's construction may have involved techniques that we do not yet understand. The combination of precision stonework, massive weights, and minimal archaeological evidence leaves modern researchers questioning whether traditional explanations can fully account for this ancient wonder. One of the most astonishing aspects of the Great Pyramid is how it seems to encode mathematical constants. Scholars and researchers have noticed that the pyramid's design reflects ratios linked to pi, p, and phi, f. Pi, the circle constant, appears in the relationship between the pyramid's perimeter and height. Phi, the golden ratio, emerges in the proportions of the sides and the slope of the pyramid. Even more surprisingly, the pyramid's dimensions seem to mirror the size of the Earth. When scaled up, its measurements correspond to the planet's circumference, polar radius, and even the length of a day in seconds. For example, some researchers point to the 43,200 ratio. The number of pyramid units multiplied by 43,200 aligns closely with key Earth measurements. This is more than coincidence. These ratios suggest a deep understanding of mathematics and astronomy. For a civilization using only rudimentary tools, achieving such precise numerical and spatial relationships seems almost impossible. Modern engineers and mathematicians are baffled that the ancient builders could incorporate planetary scale constants into a structure of stone without advanced measurement instruments. Some argued that these patterns were intentional, a symbolic way of linking the pyramid to the cosmos and the Earth itself. Others suggest the precision hints at lost knowledge, or even an understanding of planetary dimensions that seems far beyond what Bronze Age humans could have known. What is clear is that the Great Pyramid is not just a tomb or monument, it is also a mathematical statement carved in stone. Its proportions, ratios, and alignments continue to puzzle experts, suggesting that the builders had an advanced understanding of geometry, measurement, and perhaps even astronomy that modern scholars are only beginning to grasp. The presence of pi, phi, and Earth scale ratios adds yet another layer to the mystery. The Great Pyramid may have been designed not only as a physical structure, but also as a mathematical and cosmic symbol, encoding knowledge that resonates across time and space. The Great Pyramid is more than a stone monument. It's also an astronomical puzzle. Researchers have long noticed that its layout aligns with stars in the night sky, particularly Orion's belt. The three pyramids of Giza seem to match the positions of the three stars in Orion's belt almost perfectly. This correlation has led some scholars to suggest that the pyramids were designed to reflect the heavens, linking earth and sky in a symbolic and possibly religious way. Even more fascinating is the connection with the Milky Way. The Nile River appears to mirror the Milky Way's path, running in the same direction, relative to the pyramids as the galaxy's bright band of stars. This alignment hints at a deep understanding of the night sky and a desire to incorporate cosmic patterns into terrestrial architecture. Dating these alignments is another mystery. Some researchers have suggested that the positions of the stars as they would have appeared in the distant past point to a date around 10,500 BC, thousands of years before Khufu's reign. If this is accurate, it raises the possibility that the pyramids encode knowledge of the skies from a far earlier civilization, or that they were built on top of an older structure whose astronomical significance was preserved. The Orion correlation and Milky Way alignment suggest that the Great Pyramid was not just a tomb or a monument of power. It was also a cosmic map, a way to connect the Earth with the heavens and perhaps to encode knowledge about time, astronomy, and the universe itself. The interior of the Great Pyramid is not only visually impressive, it also has fascinating acoustic qualities. The King's Chamber, in particular, appears to have been designed with sound in mind. Researchers have measured specific resonance frequencies inside the chamber, noting that it amplifies certain tones in unusual ways. The granite used in the pyramid is rich in quartz, a mineral known for its piezoelectric properties. This means that when the stone is stressed or vibrated, it can produce small electrical charges. Some researchers suggest that this could enhance the acoustic effects, creating a space where sound behaves differently than in ordinary stone rooms. The question arises, was this intentional? Did the builders design the King's Chamber to resonate at certain frequencies for ceremonial or spiritual purposes? Or could sound have served a more practical function, such as communicating signals within the pyramid, or even affecting the stones themselves during construction? Experiments in the chamber show that specific tones can produce strong standing waves, reinforcing the idea that sound may have been more than a byproduct of architecture. Whether for ritual, symbolic, or technical purposes, the pyramid's acoustic properties add another layer to its mystery. It suggests that the builders were not only master masons and astronomers, but also had a keen understanding of sound and vibration, knowledge that remains largely unexplained today. One of the most puzzling aspects of the Great Pyramid is how its internal chambers were lit during construction and use. The corridors and rooms, especially the King's Chamber, are completely enclosed with no natural openings, yet there is no evidence of soot, burn marks, or residue from torches or lamps. Researchers have tested the mirror theory, which suggests polished surfaces could have reflected sunlight deep into the chambers. While mirrors can produce some light, experiments show that they cannot illuminate the vast interior sufficiently for workers to see clearly, particularly in narrow passageways and hidden rooms. This has led scholars to explore alternative explanations. Some proposed that the builders may have used reflective materials or oil-based lamps that burned without leaving traces, though no physical evidence of these materials has been found. Others suggest that the chambers were designed to enhance natural light entering through small openings, bouncing it along reflective surfaces, though the effectiveness of this method is still debated. The mystery remains. The pyramid's interior is vast and precise, yet it seems to have been illuminated without leaving typical signs of fire. This raises questions not just about construction methods, but also about the ingenuity and knowledge of light and optics possessed by the ancient builders. While the Great Pyramid is traditionally described as Pharaoh Khufu's tomb, the evidence inside tells a very different story. The King's Chamber contains a massive sarcophagus, but it is empty. No mummy, no royal jewelry, no ritual offerings, nothing at all. This is unusual because other tombs from the same era, even smaller ones, are usually filled with objects meant to accompany the ruler in the afterlife. The emptiness of the pyramid raises questions. If it was meant to house a king, why is there no trace of him or his treasures? Beyond the missing burial artifacts, the pyramid's design itself suggests purposes that go far beyond serving as a simple tomb. The structure is astronomically aligned, mathematically precise, and acoustically tuned, features that are not necessary for a burial chamber. These qualities hint at a ceremonial function, possibly as a sacred space for rituals tied to the heavens, the sun, or the cycles of the Nile. Some researchers propose that the pyramid could have served as a temple or a cosmic observatory, a place where ancient priests or astronomers studied the stars and recorded celestial knowledge. There is also the possibility of a scientific or experimental purpose. The builders may have been exploring the properties of sound, light, and stone, experimenting with resonance in the chambers or observing celestial alignments through the hidden shafts. The precision of the stonework and the alignment to true north, along with the use of quartz-rich granite, suggest knowledge that goes beyond simple construction. Perhaps the pyramid was a center of learning, a monumental laboratory of geometry, astronomy, and natural phenomena. Even its empty sarcophagus could support this theory. Rather than being a grave, it might have served as a symbolic or ceremonial element, representing the king or the Earth's connection to the cosmos. It could also have been a focal point for rituals involving sound, vibration, or even symbolic measurements of the universe, tying together spirituality, science, and state power. The idea that the Great Pyramid was more than a tomb reshapes how we view ancient Egypt. It transforms the pyramid from a static burial site into a dynamic monument, a testament to human ambition, ingenuity, and curiosity. It forces us to consider that ancient civilizations may have had knowledge, skills, and purposes that we have only partially understood. Rather than just housing a king's body, the pyramid may have been designed to inspire, teach, and connect humanity to the cosmos in ways that are still mysterious today. Ancient Egypt was a civilization deeply concerned with legacy, memory, and authority. Pharaohs did not just rule, they wrote history in stone. One of the more surprising aspects of this obsession is the practice of usurpation, where a ruler would claim or modify monuments built by predecessors to enhance their own legacy. The Great Pyramid, often attributed to Khufu, may be a prime example of this practice, and understanding usurpation sheds new light on its mysterious origins. Throughout Egypt's history, pharaohs frequently recarved inscriptions, added their names to temples, or restored older structures in a way that presented them as the original builder. Ramses II, one of Egypt's most famous rulers, is a well-known case. He often replaced the names of earlier kings with his own, claiming monuments and temples that were centuries old as his own accomplishments. In many cases, these alterations were so thorough that later generations could hardly tell who had truly built the original structure. The implications of this practice for the Great Pyramid are significant. While traditional accounts credit Khufu as its builder, some researchers argue that he may have been more of a restorer than the original architect. If the pyramid predated Khufu by centuries, or even by nearly a millennium, as suggested by carbon-dated cedar fragments and geological evidence, it is possible that his reign simply saw the final modifications, completion, or ceremonial adoption of a much older structure. By inscribing his name and associating himself with the pyramid, Khufu could solidify his connection to divine power and the cosmic significance of the monument. Evidence of usurpation appears throughout Egypt in smaller pyramids, temples, and statues. Archaeologists have discovered erasures, overcarvings, and mismatched inscriptions, showing that later rulers often wanted to overwrite history in their favor. This wasn't considered deceitful at the time. It was a means of demonstrating legitimacy, divine sanction, and political continuity. By claiming an impressive existing monument, a pharaoh could project authority and greatness far beyond his own lifetime. The practice also reflects the fluidity of history in ancient Egypt. Historical narratives were not fixed. They were tools for power. The Great Pyramid, with its alignment to stars, mathematical precision, and acoustic properties, would have been an irresistible symbol for any ruler seeking to associate themselves with cosmic order and divine favor. Even if Khufu did not personally oversee the entire construction, attaching his name to the pyramid ensured that generations would remember him as the king behind one of the greatest monuments in human history. Usurpation also complicates modern interpretations. Archaeologists and historians relying solely on inscriptions or later accounts may be attributing achievements to rulers who were, in fact, adopters rather than original builders. This could explain why the pyramid's technological feats, precision stonework, astronomical alignments, and acoustic chambers seem so far ahead of what we know Khufu could have achieved with Bronze Age tools. The true innovators may have lived centuries before, and their contributions were simply absorbed into Khufu's legacy. Considering usurpation opens the door to a different understanding of the Great Pyramid. It suggests that the monument was not just the product of a single reign, but a cumulative achievement, refined and completed over generations. Khufu's role may have been crucial in consolidating, restoring, and consecrating the structure, but he might not have been its original architect. Recognizing this possibility allows us to see the pyramid not merely as a tomb, but as a dynamic symbol of continuity, power, and the passage of knowledge across centuries. The Giza Plateau is more than a collection of pyramids and monuments. It is a layered landscape of history, meaning, and cultural memory. Each structure on the plateau has passed through multiple phases of use, reinterpretation, and ownership, creating a complex tapestry in which the original builder's intentions are often obscured. Understanding this layered ownership helps explain why the origins of the Great Pyramid and even the Sphinx remain mysterious. Take the Sphinx, for example. Its story in historical records is as much about rediscovery as it is about creation. By the time Greek historians wrote about it, the Sphinx had already been partially buried in sand for centuries. Later rulers, including Thutmose IV, restored and recarved inscriptions, leaving behind a record that framed the monument in the context of their own authority. The original purpose, builder, and meaning of the Sphinx were already obscured, layered beneath centuries of reinterpretation. What we know about the Sphinx is therefore filtered through multiple eras of reclamation and symbolic ownership. The Great Pyramid itself demonstrates similar patterns. Monuments at Giza were rarely static. They were reused, adapted, or repurposed over time. Blocks were removed, chambers altered, and inscriptions overwritten. Each generation left its mark, creating a form of historical layering in which authorship became a shared or disputed concept. A king could claim a monument as his own, priests could consecrate it for rituals, and later cultures could reinterpret it for religious, astronomical, or political purposes. This process made the pyramid not just a construction, but a living artifact of layered human engagement. This layered ownership also extends to the symbolic significance of the monuments. Giza was more than a royal necropolis. It was a sacred landscape, a physical embodiment of cosmic order, divine authority, and cultural continuity. In this context, ownership is less about who originally built the pyramid or carved the Sphinx, and more about who held spiritual or ceremonial authority over them. A later pharaoh, priest, or scribe could claim stewardship of the sacred site, interpreting and adapting it to reflect their own vision of divine or cosmic legitimacy. Reused and reinterpreted monuments complicate modern efforts to assign credit. Carbon dating, inscriptions, and archaeological evidence often point in conflicting directions, but the truth may be that the Giza Plateau was never owned in the sense of single authorship. It is a palimpsest. Each layer of use, adaptation, and cultural meaning adds to its story, but also obscures the original one. The monuments were continually engaged with, not just by builders, but by rulers, priests, and common people over millennia. This perspective challenges the idea that historical monuments can be definitively assigned to a single individual or era. The Great Pyramid and the Sphinx are less artifacts of a single ruler and more enduring symbols of collective memory, cultural inheritance, and sacred authority. Their significance transcends any one lifetime or reign, accumulating layers of meaning that continue to inspire wonder and debate today. Understanding layered ownership also provides insight into why modern researchers find Giza so enigmatic. Every stone, chamber, and inscription carries multiple histories, some of which contradict others. The pyramid may have been begun in one era, restored in another, and ritualized in yet another. The Sphinx similarly was shaped, buried, and recarved through centuries of shifting interpretation. In both cases, the true author is impossible to pinpoint. Ownership is a continuous evolving process rather than a fixed fact. In this sense, Giza is not merely a historical site. It is a living dialogue between civilizations. Its monuments survive because each generation found meaning in them, adapted them, and passed them forward. By thinking in terms of layered ownership rather than singular authorship, we can better appreciate why the plateau remains one of the most mysterious and compelling landscapes in human history. The Great Pyramid and the Sphinx are not just relics. They are enduring symbols of humanity's ability to layer culture, meaning, and sacred inheritance over time. Long before dynastic Egypt officially began, there may have been earlier cultures living along the Nile. Archaeologists call this time pre-dynastic, but that label simply means before recorded kings, not before intelligent people. These early societies understood the land, the stars, the seasons, and stone. What they lacked in written language, they may have made up for in practical and symbolic knowledge. If such knowledge existed, stone would have been the safest place to store it. Papyrus rots, wood burns, oral tradition fades, but architecture lasts. The Great Pyramid is built with extreme care and intention. Its proportions reflect mathematical constants. Its orientation mirrors the earth and the sky. Its chambers behave in unusual acoustic ways. These are not random features. They suggest planning guided by rules, measurements, and understanding, knowledge embedded directly into the structure itself. In this sense, the pyramid functions like a library without books. Instead of writing formulas, the builders expressed them through angles and ratios. Instead of drawing star maps, they aligned stone with the heavens. Instead of explaining Earth's scale, they encoded it into dimensions. Anyone who understands the language of geometry, astronomy, and measurement can still read the pyramid today. This idea also explains why so little is written down. If knowledge was already preserved in architecture, written explanations may not have been necessary, or may have been meant only for initiates. The pyramid itself became the teacher. It also helps explain why later civilizations struggled to replicate it. The knowledge required to design such a structure may have been inherited, partially understood, and eventually lost. Later builders copied the shape but not the deeper principles. The result was smaller pyramids, less precise, missing the original mastery. Architecture, in this way, becomes memory. The Great Pyramid remembers things humans forgot. It remembers a time when observation of nature was patient and exact, when builders worked with the earth, not against it, when stone was not just material, but language. Each block placed carried meaning beyond function. This may also explain why the pyramid feels timeless. It does not belong fully to Khufu's era or to any one period. It feels older because the knowledge inside it is older. It may represent the final expression of a long tradition rather than the sudden invention of one ruler. If pre-dynastic civilizations existed with advanced understanding of mathematics, astronomy, and natural forces, the pyramid may be their legacy. Preserved, reused, renamed, but never fully erased. Later kings may have inherited it, restored it, and claimed it, but the core intelligence remained untouched. Seen this way, the Great Pyramid is not silent at all. It speaks through alignment, proportion, and precision. It tells a story of continuity rather than beginnings, of knowledge passed forward, not invented overnight. The tragedy is not that we do not know who built it. The tragedy is that we may no longer fully understand what they knew. Human history is often told as a straight line, simple beginnings, steady progress, modern advancement. But the Great Pyramid challenges that idea. Its existence suggests a different pattern, one of cycles. Civilizations rise, reach great heights, and then fall, sometimes suddenly, sometimes violently. One event often mentioned in this context is the Younger Dryas, a period around 10,800 to 9,600 BC when Earth's climate changed rapidly. Evidence from ice cores, sediment layers, and flood patterns suggests massive environmental disruption. Temperatures dropped, glaciers melted, sea levels rose, and floods reshaped landscapes across the world. Human societies that depended on stable climates may have been wiped out or scattered. Ancient myths seem to echo this memory. Stories of great floods appear in cultures across the globe: Egypt, Mesopotamia, India, the Americas. These myths often speak of gods, judgment, and a small group of survivors who carried knowledge forward. While modern thinking treats these stories as symbolism, their global similarity raises questions. Were these myths distant memories of real cataclysms? If advanced societies existed before recorded history, a disaster like the Younger Dryas could have erased most traces of them. Cities would sink, coastlines would vanish, and written records would disappear. What would survive? Stone, geometry, monuments built to last. In this view, the Great Pyramid may be a survivor of such a cycle, not built after catastrophe, but in response to it. A structure designed with permanence in mind, a way to preserve essential knowledge of the earth, the sky, and measurement beyond the fragile span of any one civilization.